All right, let's get right into it. We've all seen AI that can write a poem or paint a masterpiece in seconds, and that's been pretty mind-blowing. But what if I told you that was just the warm-up act? Because NVIDIA just pulled back the curtain on a plan so big, it's not about redesigning our digital world anymore. It's about rebuilding our physical one.
And this is the number that should make you sit up and pay attention. $50 trillion. You heard that right. When the CEO of NVIDIA throws a number like that out there, it's not a wild guess. It's a target. That's the estimated value of the entire global industrial economy, and NVIDIA just put a bullseye on it. So to understand what's happening, you've got to get this key difference. On the left, that's the AI we're used to, right? It lives in the cloud, it makes digital stuff, like text and images. But on the right, that's physical AI, and it's a whole different beast. It doesn't know about sonnets, it knows about physics. This is the AI that's going to run our factories, manage power grids, and command entire fleets of robots in the real world. Okay, so that leads to the billion-dollar question. How in the world do you teach an AI about reality? I mean, you can't just unleash a rookie algorithm in a multi-billion-dollar factory and hope for the best. The slightest mistake could be catastrophic. And this is where NVIDIA's strategy is just absolutely brilliant. The heart of their entire plan is this concept, the digital twin. And no, we are not talking about some basic 3D model. The best way to picture it is like a high-tech voodoo doll. It's a perfect one-to-one virtual copy of a real factory or a city grid or even a human heart. It's constantly updated with live data, and it simulates real-world physics perfectly. So if a robot arm is about to break in the real world, it breaks in the simulation first. And this really hits the nail on the head. A blueprint? That's just a dead piece of paper, a snapshot in time. A digital twin is alive. It's a virtual sandbox, a playground, where an AI can get 1,000 years of real-world experience in a single afternoon. It can run millions of tests, make 1 billion mistakes, and learn from every single one without costing a dime or risking a single life. So here it is, the secret sauce, NVIDIA's 4-step playbook, all running on their Omniverse platform. It's so elegant. Step 1. Build that perfect physics-accurate digital twin. Step 2. Use that twin as a data factory to create a never-ending stream of perfect, pre-labeled training data, the kind you could never get from the messy real world. Step 3. You let your physical AI train in this digital paradise until it's a world-class expert. And then finally, Step 4. You deploy that seasoned, expert AI into the real world, ready to perform flawlessly from day one. They're not just building AI, they're building a factory for reality itself. But look, a plan this huge needs an engine unlike anything we've ever seen before. So let's pop the hood and take a look inside the AI factory. Because NVIDIA isn't just giving its chips a little upgrade, they are fundamentally rethinking what computation even means to make this future possible. And they are moving at a truly terrifying pace. For decades, the tech world lived by a simple rule: a new chip generation every 2 years. Well, that rule is dead. NVIDIA has officially switched to a 1-year cadence. Blackwell is out now, Rubin is coming in 2026, Rubin Ultra in 2027. The hardware is literally evolving faster than most people can keep up. So why the insane speed? Because the job of the AI is changing. The Blackwell chip we have now, it's built for what you could call System 1 thinking. It's fast, it's reflexive, it's great at predicting the next word in a sentence. But Rubin is being designed for System 2 thinking. This is for agentic AI. An agent doesn't just give you an answer, it plans. It simulates thousands of possible outcomes. It reasons its way to a solution before it acts. It actually thinks. Now, this is where it gets really interesting, because to pull this off, NVIDIA made a massive bet. You see, with Rubin, the performance for AI-specific calculations is going to jump 2.5 times. Huge! But look at the trade-off. For traditional high-precision scientific computing, the kind used for climate models, performance actually goes down by 27%. NVIDIA is actively sacrificing old-school computing power to go all in on AI. And to make this beast of a chip possible, they basically had to cheat physics. First, they're using HBM4 memory, which is like turning a 2-lane country road into a 4-lane superhighway for data. Second, they're using a new 3-nanometer process to shrink everything down. And third, and this is the craziest part, they hit a literal wall. A chip can only be so big. So what did they do? They started building up, stacking components vertically like a silicon skyscraper. Now, of course, a move this big doesn't go unnoticed. When you're trying to build the future, you can bet that everyone else wants a piece of it. And the war for AI dominance isn't just about who has the fastest chip. It's a battle being fought on all fronts.
You know, NVIDIA's biggest weapon isn't really their silicon, it's their software. And this quote just nails it. For almost 20 years, they've built this software platform called CUDA. It's become the air that AI breathes. An entire generation of developers and scientists have built their careers on it, creating this incredibly deep, sticky moat that's almost impossible to escape.
So how do you compete with that? Well, companies like Google and Meta know they can't just build a better chip. Their whole strategy is to attack the software moat. By backing open source tools like PyTorch and making them run great on their own hardware, they're trying to make CUDA less important. Their goal is to make the hardware underneath totally interchangeable, to turn NVIDIA's GPUs into just another commodity. And NVIDIA's response? It's a stone-cold power move. They're building a new moat. But this one isn't made of software code. It's made of actual silicon and factories. They've reportedly gone out and booked over half of the entire planet's advanced chip manufacturing capacity for 2026. It's simple, really. If your competitors need special factories to build their chips, you just buy up all the factories. But this all-out tech war isn't happening in some abstract digital space. It has very real, very tangible consequences. Building this new reality takes an incredible amount of physical resources, and it's creating ripple effects that we're all about to start feeling. Let's just start with pure power. A single server rack of their current Blackwell chips already uses about 120 kilowatts. The next-gen Rubin rack? That's expected to pull down over 250 kilowatts. That is enough energy to power dozens of houses, all concentrated in a box the size of a refrigerator. You can't cool that with fans. You have to pump industrial-grade liquid through it just to keep it from melting. And that's just one piece of the reality check. This enterprise AI war has knock-on effects. The supply chain is getting squeezed. And for any gamers watching, here's the bad news. Reports suggest there won't be a new consumer RTX graphics card in 2026 because NVIDIA is pouring everything it has into the data center market. And of course, when your company is worth trillions, the expectations are so astronomically high that any tiny stumble could cause chaos in the market. So when you put it all together, it's pretty clear we are standing right at the dawn of the physical AI age. The hardware is being forged in this incredible tech race, the software is being written, and the power to fundamentally redesign our physical world is, for the first time, on the table. And that leaves us with the most important question of all, the exact same one that people building this technology are asking themselves. With all this power, what should we build first?